Hey everyone, here's a question for you. Do you love science as much as you love delicious snacks? Well, if so, let me tell you about today's sponsor, Master. They ship these incredible high-quality food boxers straight to your door, featuring curated ingredients from around the country and the world. So you get to try things you might not normally have access to. Like right now, they've got their Japanese snack box, which lets you experience the art form that is Japanese snacking. It's full of 30 authentic snacks like savory rice crackers, thick-cut toast, seaweed, and cookie bites. And my favorite, these tuna pie puffs. They're flaky, creamy, and fishy. Delicious! Plus, each snack has a little card telling you all about it. So you'll learn about Japanese culture while you munch. And since I know you're going to want more, Masterworks is offering SCI Show viewers like you an exclusive deal. Head to the link in the description or use the code SCI Show at checkout to save 15% off your first box. Thank you, Masterworks, and thank you for supporting this channel. And now, back to the video. There are layers upon layers of Earth's crust beneath our feet, and according to some estimates, just below the deepest parts of those layers lies a sea of water. That's right, an entire ocean that is nearly twice as big as our own exists underneath Earth's solid outer layer. Now, if that doesn't blow your mind enough, wait until we tell you that it's also warm enough to melt rock. In the grand scheme of things, finding this subterranean ocean was pretty much an accident. For decades, geologists believed that Earth's mantle, the layer between the crust and the core, was completely dry. After all, it's about 2,900 miles from the nearest sea. Then in 2014, a team of Chinese scientists who were studying seismic data from an earthquake that hit northern Taiwan in 1999 noticed something strange. They were looking at how seismic waves move through the different layers of Earth, when they realized that in one particular area, the waves seemed to slow down. And not just slightly, they found that the waves that passed through a zone about 400 miles underground took 4 times longer to travel through that area compared to the surrounding rocks. Now, scientists already knew that minerals within Earth's mantle could absorb water and other elements. We're talking about a process called metastasization, which basically means the minerals trade some of their ions for others that are floating by. You see, the stuff that makes up Earth's mantle isn't just one mineral, but a whole bunch jumbled together. The most common types are silicate minerals like olivine and pyrite, which are made of silicon and oxygen along with magnesium or iron. These minerals are like a buffet. They'll happily swap ions with just about anything that happens to pass by. For instance, if seawater seeps into the cracks of the crust and makes its way into the mantle, the minerals will swap sodium, potassium, and calcium for hydrogen. But they're especially good at grabbing onto water molecules. The thing is, even though the researchers knew that metasomatism happened, they didn't think it would make much of a difference. Because 400 miles under the surface, the temperature is around 80 and 100 degrees Fahrenheit. At that heat, water shouldn't be able to stick around in any form. It should either turn into steam and escape back up to the surface or dissolve into a mineral lattice as a negatively charged ion. So why were these seismic waves slowing down? Turns out the answer was hiding in plain sight. In 2015, another team of researchers presented their findings about ringwoodite, a rare mineral that's only stable deep in the Earth's mantle under high temperatures and pressures. They found that unlike other silicate minerals, ringwoodite holds onto water really well, thanks to its unique structure. Each ringwoodite molecule acts like a tiny sponge, trapping 2 water molecules inside of it. Now, we don't actually have any ringwoodite in our labs to test this out, at least not yet, but based on computer models and experiments conducted with similar minerals, scientists are fairly confident that this is the explanation for the mysterious slowdown. That means there could be a lot of water trapped inside Earth's mantle, like a lot. According to one estimate, just 1% of the ringwoodite in Earth's mantle is enough to hold 3 times all the water in Earth's. But if ringwoodite is such a great sponge, where did all that water come from? It turns out that scientists have 2 competing theories. First, some researchers think that the water came from outer space. According to this hypothesis, 4.5 billion years ago, when Earth was still very young, comets and other icy space rocks bombarded it and delivered tons of water. Over time, some of that water made its way into the mantle. And if you're wondering how it managed to survive those high temperatures, keep in mind that we're talking about depths of hundreds of miles. Even at the deepest parts of the mantle, the temperature never gets above 4,800 degrees Fahrenheit. So there's plenty of room for liquid water to exist alongside molten rock. Other scientists aren't convinced. They think that Earth formed with water already inside of it, and it has been leaking out ever since. Basically, this is a case of Earth sweating out its ancient water. How do they know? Well, they studied volcanic eruptions. See, when magma bubbles up from deep inside Earth to form volcanoes, it brings minerals with it. And the type of magma that comes up depends on what kind of rocks it started in. Magma's made from the stuff that's closer to the core tend to be more iron and magnesium rich. Meanwhile, magmas that originated deeper in the mantle often contain more, and as it turns out, The amount of water they carry along for the ride depends on what part of the mantle they are coming from. Magmas that originate near the bottom of the crust have less water in them, while those that start deeper in the mantle have much more. And given that volcanoes are Earth's pressure relief valves, scientists think that all this water might be coming from the same giant subsurface ocean. But while there's evidence to support both of these theories, we just don't have enough proof to say for sure which one is correct. Now, whether it comes from outer space or is native to Earth, this hidden ocean has some pretty crazy implications. It means that if we ever wanted to, we could turn Earth into a water park. Just drill down deep enough and hook up the pipes. Well, maybe not exactly. You see, the water itself probably wouldn't be very useful to us. It's deep enough that the pressure is around 3.6 million. To put that in perspective, the pressure at the bottom of the Mariana Trench, the deepest part of Earth's ocean, is about 1,000 SI. So you'd need some very strong pipes, not to mention the fact that it's also 1,000 degrees Fahrenheit. Still, the discovery of this subsurface ocean could be a huge deal for humanity. According to one researcher, it completely changes everything we know about our planet. For one, it could help us find extraterrestrial life. As you may have noticed, Earth's surface isn't exactly teeming with life. Most organisms live underground or in the water. And given that there's a lot more rock than water on the inside of our planet, it stands to reason that there could be even more life there. Sure, we haven't found any yet, but in 2014, scientists found bacteria living 12 miles underground in a South African gold mine. If life can thrive that deep, who knows what could be lurking deeper down where the water is? Then again, the water itself could be the life. NASA believes that conditions in this deep ocean could be similar to those on early Earth, meaning it could be a great place to study or if we can find life there at all, it could even change the way we define life. Who knows? Maybe we'll find sentient beings that can talk to us about the nature of reality. Well, maybe not that last one, but hey, a gal can dream. Ultimately, this subsurface ocean is a reminder that even though we like to divide up Earth's layers into neat categories like crust, mantle, and core, they're all interconnected. And that goes double for our planet's water cycle, which moves freely between the atmosphere, hydrosphere, cryosphere, and lithosphere. In the end, Earth didn't just have water, it is water, a giant, layered ocean planet, with a thin crust we call land. If we can find ways to safely drill deeper into the planet, maybe we'll uncover more surprises. So here's hoping that someday we can explore this alien world without having to brave thousands of degrees of heat. Hey, if we can send people to the moon, we can do it. Thanks for watching this episode. Drop A in the comments if you'd brave the heat to explore this underwater world. And subscribe, because next week, we're revealing why scientists think Europa's ocean could be home to giant squid.